Hello, everyone. This is the presentation for my KaggleX BIPOC Mentorship Program project. As part of this program, my mentor, Mensur Dlakik, and I took part in a competition called Auto, which was a multi-objective recommender system. My mentor is a professor of microbiology at the Montana State University, and he is also a Kaggle competition master. So we both formed a team and took part in this competition. Before I get into the details, here's a little bit of background about myself. I have an MBA from Syracuse University. I currently work as a data scientist at Cossette Media. And if you click on this link over here, you can see some of the projects that I have done. And I've also recorded the KaggleX program project in my portfolio. So my aspirations are to be able to work as a data scientist in an organization where the product is driven by data science. I want to expand the breadth and depth of my ML knowledge and also work as an ML engineer. And eventually I want to become a mentor. The objective of this project was to predict clicks, carts, and orders for every session in the test set. There were no features that were provided, so this was an implicit recommender system. Um, I will show the blog post a little later where I have summarized the entire project. Some of the topics that I learned during this competition were how to create a robust local validation framework. I learned about the two major building blocks of recommender systems, which are retrieval and ranking. Retrieval is used to generate candidates, and ranking is used to rank those candidates to provide the most likely article to recommend. The libraries that I used for any sort of data manipulation were Polars, Pandas, and NumPy. Polars, especially, is a very good library to do fast transformations on large data sets. Then I also learned about matrix factorization using PyTorch and Word2Vec using GenSim, and I trained my ranker model using XGBoost. At a high level, this is the project pipeline. Um, It's divided into retrieval versus ranking. Retrieval is the process of generating candidates, while ranking is the process of ranking them. It's pretty intuitive. My mentor, Mensur, we formed a team and we entered the competition. We actually ended up moving 167 places up in the final leaderboard with a final rank of 477 out of around 2,500 participants. Here is the blog post where I have provided a detailed background about the entire project. So the various steps involved are given in this diagram, and I've also outlined and given descriptions about each step below. One thing to note is that for my proof of concept, I did not use the actual competition data set because it was too large. It was 11 GBs and of training data and was taking too much time for every step. So I used a similar data set, which is much smaller, to be able to showcase these data sets and make it easier to showcase these processes and make it easier for anyone else to run fast. So the first part after creating the surrogate data set was to create a local validation framework where I took the training data, which was 4 months and 3 months of train and 1 month of test. I took the 3 months of training data and divided into 2 months of training and 1 month of validation. I created co-visitation matrices, which are based on the idea that pairs of events that occur in the same session within the same day uh, describe what users are more likely to buy. Using these co-visitation matrices, you generate candidates. After you generate candidates, you have a much smaller pool to rank. And so you're able to use the smaller pool to train a model. I use matrix factorization and Word2Vec to create embeddings for the articles, which would eventually translate into similarity features. I also generated a bunch of features um, for the for the e-commerce data set using the historical behavior. There were item features, there were user features, there were user item interaction features. Finally, I trained the model using XGB ranker, and this is the local score that I got with an overall recall of 65%, 64%. Now that I was happy with my local score, I repeated this entire process and trained the model using the entire training data. And then I got a test score of 64% as well. So, my major conclusion and takeaway from this project was that the best form of learning happens by doing. And I want to give a huge shout out again to my mentor, Mensur, whose advice was and guidance was extremely valuable to me throughout this entire process. Thank you.